discussing about the module 8 of the organic chemical technology, and in the module 8 we earlier discussed about the polymer elastomers, and today we will be discussing about the synthetic fiber, and already on nylon and polyester we have covered in the previous lecture, and today it will be on the acrylonitrile, acrylic fiber, polyurethane, and the next lecture that will be on the viscose yarn. So, in case of the today's lecture, that will be acrylic fiber, modified acrylic fiber, acrylonitrile, acrolein, because the acrolein, that is the byproduct we are getting during the manufacture of acrylonitrile, but some of the processes are there. In case of acrylonitrile, there will be no acrolein, propylene fiber and the polyurethane, because the propylene already we have discussed. So, the other process is same in making. So, we are not going in detail about the propylene fiber, but polyurethane, that definitely we will be discussing, because the polyurethane, that is also one of the very important class of the plastic which we could not discuss here while discussing the polymer. So, this will be the coverage of the lecture: introduction, historical review, characteristic of the acrylic and modified acrylic fiber, technological development, acrylonitrile acrolein manufacture, acrylic fiber and modified acrylic fiber, and then the first will be discussing the polyurethane and then the polypropylene fiber. This you can see the by appearance and seeing the importance of the acrylic fiber, because this is just like a wool like material, and whatever the revolution you are seeing in case of the acrylic fiber, that is because of the in the synthetic fiber, that is because of the coming of the acrylic fiber in the market, and now it has captured whole wool market and has replaced the conventional wool material that was being used for the woolen fabrics. And this is the sum of the product of the acrylic fiber, and even in case of the now the, if you see the carpet, and in case of the curtain also we are using this acrylic fiber. This is the towel, this is this sweater and other, because the woolen material, this is thread of the acrylic fiber. So, this is the how the importance of the acrylic fiber is there, and a real revolution came in the case of the acrylic fiber, that was the availability of the raw material propylene from the naphtha cracker, and then the propylene to amino oxidation process of the acrylonitrile. So, let us discuss about the first the introduction of about the acrylic fiber. Acrylic fiber is an integral part of the total textile fiber mix, which consists of the cotton, wool, silk, natural and man-made fiber. Acrylic fiber play important role in meeting the demand of one of the basic needs of the clothing, and to meet the demand of the increasing population. Driving force for growth of the acrylic fiber is mainly due to replacement of the wool, and at the same time availability of the raw material propylene, because you see the here also we will be discussing what are the various roots of the acrylonitrile, which is the main polymer here, are the sometimes it is copolymers also added there to when we are manufacturing the modified acrylic fiber, to enhance some of the property which is not inherent in case of the acrylic fiber. So, in all the whether it is acrylic fiber or modified acrylic fiber, this is because it has replaced the wool material. Even in the blanket in the market you are seeing this is all made of the acrylic fiber, and so the earlier processes which we will be discussing while discussing the acrylonitrile, that was the acetylene route or the ethylene route or the ethanol route for our acetaldehyde, because the starting for all these the your ethylene. So, that was the route for making of the, and again the major development, as I have been discussing earlier also, that the major development in case of the various petrochemical products, intermediates, and the final that was during the 1910 to 1930. That was the time of the World War I, World War II, when the lot of the requirement of the polymer, elastomer or the synthetic fiber was there. Acrylic fibers, why the importance of the acrylic fiber? Because it is having the specific property appearance like wool, which I show the in the picture, that the how it looks like. This is just like a woolen material. So acrylic fiber are characterized by softness, that is the basic requirement in case of the wool like feel, superior thermal insulation, very good shape resistance, fastness to light, moth, mildew, and the insects resistance, because these are the some of the property which is the requirement of for the carpet, which was earlier we normally it was the woolen material that was being used. And the another properties with the lightweight, resilience properties, resistance to all biological and most chemical agents, little affected by weak acids, weak alkali and organic solvent, low water absorption, quick water transport, means the drying. So that is much faster in case of the acrylic fiber, and this is the reason why the material made from the acrylic fiber, the washing is also easier, and because the water drainage is fast. Another important characteristic of the acrylic and modified acrylic fiber is their flammability and the ignition behavior, because these are the two another important in case of the modified acrylic fiber, that is the flammability and the ignition behavior. That is then because the vinyl chloride and the vinylidene chloride that has been incorporated as monomer while making the modified acrylic fiber. Acrylic fiber is available as stable and two filament products, high bulk, bicomponent fibers, and modified acrylic and the fire resistance fibers in the world. Polyester and its blend with the cotton is the most popular fiber in the India, because it has been blended, as I told you, now the whatever the synthetic fiber, various blend of the cotton or the viscose or it may be the acrylic are there just to improve the some of the property or the some of the deficiency of the polyester which is there, which is improved with the help of the when you are having the acrylic fiber or the viscose. Acrylic fiber used as a substitute for wool, as I told you. Other fibers like cotton, nylon, polyester, due to its characteristics such as the durability, bulking, superior dryability, which I was saying the water drainage property is good, easy wash and wears property. Easy wash, and because that is also one of the basic requirement in case of the textile or the when you are using the various even in case of the hosiery material, in case of the carpet you are able to wash it. In case of the acrylic fiber, use of acrylic fiber in new application has been increasing, and these are the some of the driving force for the more and more consumption of the acrylic fiber. In acrylic fiber, monomer is the acrylonitrile, while in case of the modified acrylic fiber, acrylonitrile is copolymerized with vinylidene chloride or vinyl chloride, which I told you these are the two material coordinated compounds which are being co-polymerized along with the acrylonitrile. The halogenated monomers impart flame resistance and are suitable for home furnishing, protective coatings, sleepwear and hospital blankets. So, these are the some of the advantage why we are going for the modified acrylic fiber. Usage of the acrylic fiber in new application have been increasing. Higher demand potential of the application such as blanket, stuffed toys. This is also where the we are using lot of the acrylic fiber, although the amount that is less if you compare to other uses, but in this stuffed toys we are using lot of the acrylic fiber material. Furnishing and woven garments will lead to higher demand of the acrylic fibers. Acrylic fiber plant in India includes consolidated fibers and chemicals, Indian acrylic, IPCL, in Indian petrochemical complex, that is now Reliance Industrial Vadodara. That was the one of the unit, large integrated unit that was started during the 70s, which we discussed while discussing the petrochemicals, and so that is also having the acrylonitrile plant. Pasupati Acrylic, that is one of the another major producer of the acrylic fiber, and where they are making the acrylic fiber and modified acrylic fiber. Another important Bardhaman acrylics, because Bardhaman wool and other things, they are very important, and so they have also gone in the case of making of the acrylics, because you see now the cost of the wool material, the natural wool, that is very high in comparison to the acrylic fiber, and that is the reason why it has been almost completely replaced the conventional wool material which in the hosiery and other application. So, IPCL and Pasupati Acrylic both are expanding their respective capacity. According to SRI Consulting Report 2010, the consumption of acrylic fiber were both around production consumption both were around 1.9 million tons with the global capacity utilization of 62.5%. So, the acrylic fiber use, as I told you, the substitute for cotton, nylon and polyester due to its characteristic durability, bulking, superior durability, easy wash and wear property. Acrylic fiber, already here actually how do we differentiate between the acrylic fiber and the modified acrylic fiber. Two major types of the acrylic fiber are acrylic fiber containing at least 85% by mass acrylonitrile units, Orlon, because the old one, that was the trade name that was given to the acrylic fiber, like terine or the Dacron in case of the polyester. So, Orlon, that was the name given. DuPont, because DuPont has been the pioneer in case of the synthetic fiber, whether it was the nylon or it was the acrylic fiber. So, modified acrylic fiber should have between 35 to 85% of the acrylonitrile. In case of the acrylic fiber, it is the 85% the acrylonitrile unit. Here it is around 35 to 85%, rest is the other comonomer. So, this is the basic difference, and normally as I told you, we are using the vinyl chloride and the vanillin chloride. These are the two actually the chlorinated compound which imparting the better fire resistance property to the acrylic fiber. These are the major technology supplier licenses: the DuPont, Asahi Japan, Exxon, Anta Viscosa, Monte Fiber, American Cyanide and Counterts. Development in the acrylic fiber. Specialty fibers like gel dyed, these are the another special quality of the acrylic fiber. So, the specialty fibers like gel dyed acrylic fiber, porous acrylic fibers, optically bright acrylic fiber, super bright acrylic fiber, flame retardant acrylic fiber are the some of the catalysts for the that will be discussing separately, the retardant acrylic fiber. The global acrylic fiber consumption is expected to average growth of 4.6% per year from 2009 to 2014 and around 1.1% from 2014 to 19. Apparel usage accounted for over half of the total global acrylic fiber consumption in 2009. Other applications include industrial usage and the home furnishing. This is already we discussed this part, the work condition of the non-woven man-made fiber, and here you can see the acrylic fiber around 2 to 3% that we are using even in case of the non-woven man-made fibers. This is the status of the acrylic fiber production capacity and the production in India, that is the acrylonitrile and the acrylic fiber. This is 41,000, that is the and 39,000, and the here acrylic fiber 143,000, and 91,000. This is the about the capacity and production of the acrylic fiber. This is the some of the characteristic which I discussed about the acrylic fiber. That is the acrylic fiber. Here the monomer and basic chemicals, acrylonitrile, propylene and ammonia, and the mono oxidation of the propylene that we are using here the technology. And the characteristic is density 1.17, moisture again 1.5 to 2.5, melting point around 235 degrees centigrade, silk like luster, good resistance to weathering, alkalis and acids, high bulking, and that is the property in case of the woolen material also. The tensile strength 2 to 3 gram per denier, elongation at break 16 to 21%, and at the same time its wool like appearance. That is what it is giving its use in the woolen industry, where we are making a lot of the woolen material. It may the hosiery, or it may be the blanket, or even in case of the carpet, other areas where we are using modified acrylic fibers, that is the acrylonitrile, vinyl chloride, vinylene chloride. Here propylene and ammonia and ethylene, that may be depending upon the route, but the propylene and ammonia, that is the now the most of the process they are using the propylene and the ammonia. So moisture again, melting point 235, good resistance to weathering, alkalis and acid, high bulking, good resistance to combustion. Now discuss the let us discuss the raw materials for the acrylic and modified acrylic fiber. Acrylonitrile, acetylene, because that was the earlier route, acetylene, acetaldehyde, ethylene oxide, then the propylene and ammonia. This is the now the route which we are using the raw material ammonia and propylene for the ammono oxidation of the propylene and for making the acrylonitrile. Vinyl chloride and vinylene chloride, that is needed in case of the modified acrylic fiber, and the dimethyl formamide, that is the solvent which we are using, because earlier in case of the acrylic fiber wet spinning was there, and now we are using the dry spinning in case of the acrylic fiber. This was only possible with the availability of the dimethyl formamide, and that is the product from the synthesis gas, and some of the fertilizer complex, integrated fertilizer complexes, they are making dimethyl formamide. And although the dimethyl formamide has been used as the solvent, that has been supported for other purposes also, but the changeover from the wet spinning to the dry spinning in case of the acrylic fiber, that was only possible because of the dimethyl formamide solvent. So this is the one of the important solvent, because you see, I have already discussed about the spinning. We are having the three type of the spinning. One is the melt spinning, where the polymer is melted and then it is passed through the spinnet, or in case of the dry, and that is in the solution form, and then it is passed through the spinneret, and then the drying is taking place and removal, stripping of the solvent that is there, and then we are having the yarn or the staples from that. And but in case of the wet spinning, which was earlier done, but for the acrylic fiber, that was the it was the wet spinning process, means the way spinning bath was there, through which the your material, that the polymer that was passed, and the fiber that we are getting from that. Acrylonitrile. Now let us discuss about the acrylonitrile, which is the raw material for the acrylic fiber, and the importance of the acrylonitrile. That is not only because of the acrylic fiber, but there are various combination of the acrylonitrile, betadine and styrene for making of the synthetic rubber also, which are having the better sealant properties towards oil. So acrylonitrile was first synthesized by Morio in 1893. Acrylonitrile is a versatile and the reactive chemical Acrolein was developed in 1950, which was the driving force for the development of new technology for acrylonitrile, because as I told you, there has been continuous development in the process technology from the manufacture of the acrylonitrile, and the starting that was the acetylene, as in case of the other petrochemicals which we are making to the petroleum route. CO process using ammono oxidation, that came into 1950, and after that number of the process licenses, the technology based on the ammono oxidation that has been used. Even in case of the technological development, the reactor fixed bed to the fluidized bed reactor we are using in case of the, now the most latest the fluidized bed reactor in case of the acrylonitrile manufacture. So, over the past decades, as it was the rapidly expanding market for acrylonitrile and the modified shifted towards the acrylic and the modified acrylic fiber and resins, acrylonitrile butadiene, styrene and styrene acrylonitrile. So, these are the various combination of the rubber also, which has led to the development of the acrylonitrile industry. Acrylonitrile is one of the important monomer for the acrylic fiber. Earlier routes of the acrylonitrile manufacture was the acetylene route, ethylene oxide route, or the acetaldehyde, because from the ethylene you can get the ethylene oxide to acetaldehyde, and for the ethylene the molasses route was there, and still we are manufacturing lot of the ethylene through the molasses route. So, this was the conventional method earlier before coming of the propylene route, where we are doing the ammonisation of the ammono oxidation of the propylene. So, this is the process, and the process became more cheaper because of the availability of the propylene from the steam cracker plant. This is the, if you see the how we are getting the from the acetylene route, this is the hydrocyanide, and with the reacting with the acetylene, that we are getting the acrylonitrile. Earlier this was the ethylene oxide route, and ethylene oxide to we are cyanohydrin to acrylonitrile. So, by dehydration. So, these were the another technology that was earlier used before coming of the your propylene, the ammono oxidation of the propylene. Another process, that is the acetaldehyde route. Again acetaldehyde, as you know, that we are making through the ethylene route, so that is also available, and then we can make the acetylene. But if you see the propylene route, now it is more common, and most of the, even DuPont in the earlier stages they use some other technology, not the ammonia, but that was the oxides of the nitrogen for the propylene route. But here again, and direct, that is also we are getting from the process during the process itself, NH3 and the oxygen is there, and so this is the process ammono oxidation of the your acrylonitrile, this propylene to acrylonitrile, that the process we are using. Another two-step process that we are having, because you see the propylene, how to get the propylene, because it is not only the cracker, but also we can get the propylene from the dehydrogenation of the propane, that is the on purpose propylene, and so the propylene to propane to propylene, and followed by ammono oxidation of the propylene. So, this is the how the various technological development that has taken place regarding the raw material. But you see the one of the method which I told you, because most of the development in the earlier stages of the organic chemical industry, that was the acetylene route, and for that, as you know, the calcium carbide to acetylene, and that is the we need the your limestone and the coal. So, that was the process earlier that was used for the making of the and then it was of course the ethylene oxide, and the ethylene oxide again you can get the ethylene from the alcohol. Now, let us discuss about the acrylonitrile from the propylene route. Acrylonitrile is one of the important monomer for manufacture of acrylic fibers. However, earlier routes of the acrylonitrile manufacture of acetylene by acetylene ethylene oxide acetaldehyde route has been replaced by propylene route due to the availability of the cheaper propylene from steam cracker especially. The process involves a monooxidation of propylene. Other uses of acrylonitrile are in the manufacture of nitrile rubber, ABS, acrylonitrile butadiene styrene or the styrene acrylonitrile plastic, adiponitrile and the acrylamide. These are the other uses of the acrylonitrile, and this is one of the major, that is the ABS acrylonitrile butadiene or the styrene acrylonitrile plastic and the elastomers also. This is the one of the important outlet for the acrylonitrile. In addition to it, it is also used in the manufacture of acrylates, intermediate for flocculants, pharmaceutical, antioxidants, dyes and surface active agent. The catalyst, the various stages involved. First is the catalyst preparation, bismuth and molybdenum catalyst, mixing of the propylene, ammonia and oxygen in this ratio along with the catalyst. Then the reaction vessel where the your acrylonitrile, acetonitrile, hydrogen cyanide, unreacted mixture of the propylene, ammonia and oxygen are fed to the fluidized bed reactor. Various production reaction product from the reactor are the acrylonitrile, acetonitrile and the hydrocyanide. These are the some of the raw byproduct also we are getting along with the reaction. Reaction is highly, this reaction of the because as you know we are doing the oxidation, so this reaction is highly exothermic. Absorption, the next stage, the absorption of the component from the ammonia free gas in water to separate the non-condensable and unconverted propylene, propane, nitrogen, Cu and CO2. Removal of the ammonia, stripping of the organic components and separation of the hydrogen cyanide. Separation of the acrylonitrile and acetonitrile, which are because here also because the acrylonitrile and the acetonitrile they are having the close boiling point. So, that is separated by extractive distillation column using water as a solvent, because this is otherwise it may not be possible, it will be not possible for separation of the acrylonitrile and the acetonitrile. Then the dilute solution of acrylonitrile is separated, which is recovered and concentrated. Purification of the acetonitrile, final purification of the acrylonitrile. Because this is the process which we are using in case of the acrylonitrile manufacture. I told you that normally now the most of the technology they are based on the fluidized bed reactor, but in the early stages it was the fixed bed reactor that was being used for the manufacture of the acrylonitrile. So, the propylene and ammonia in the air, that is going to fluidized bed reactor, cyclones are there for separation of the catalyst, and then it is going to the absorber, separator, then the azeotropic distillation for the separation of the acrylonitrile, and here actually the acetonitrile, that is going to the your again separator, and then the finally the acetonitrile that we are getting as a byproduct. So, this is the process that we are using in manufacture of the acrylonitrile. So, this was the major, because in the process acetonitrile that will be also formed, and so that will be important byproduct of the acrylonitrile. Or now the technology are also there that may be the acetonitrile, that may be optional, as in case of the DuPont process. In this process, the DuPont process, acrylonitrile is made by oxidation of propylene and ammonia in a fluidized bed reactor using proprietary catalyst. The process produces high purity acrylonitrile, hydrogen cyanide and acetonitrile. So, this is the about the, but here as I told you, the acetonitrile that may be optional also. Then the another process that has been, that the monetization UOP process. Here also we are using the same fluidized bed reactor. In this process, amino oxidation of the propylene is done in fluidized bed reactor, which give better temperature control and remove the impurities and remove the limitation of propylene ammonia concentration, because here the explosive mixture that is there in case of the propylene and ammonia. So, this process remove the limitation of the propylene ammonia concentration due to explosibility of the feed mixture. The process is characterized by high conversion rate, and which is the basic requirement in case of the any process. This is the reaction in case of the your acrylonitrile manufacture, and we are in the process we are also getting the acetonitrile. This is the your oxygen of propylene oxide from the propylene oxide and the ammonia that we are using for the acrylonitrile. This is the overall reaction that is taking place. These are the side reaction that is taking place in case of the acrylonitrile, where the SCN or the CH3 acrylonitrile is there. So, that is the how the separation that can be there for the separation of SCN and the acetonitrile. Now, let us come to the fiber part, because the from the acrylonitrile to acrylic fiber, the process technology, the two major steps are there in the polymerization and then spinning, and after the spinning definitely the fiber which is coming, that will be going for the dyeing and the cutting, baling, that is the different, that will be always there in all the process that is there. So, polymerization includes the copolymer composition, catalyst system, polymerization reaction and monomer recovery. So, copolymer means when we are going for the modified acrylic. Spinning process, this includes solution or the dope preparation, or it may be the dry spinning, spinning techniques and finishing operation including after treatment, cutting and baling. Then the major polymerization process are bulk polymerization, suspension polymerization, emulsion polymerization, the solution, all the four processes that can be, but the common process which are using for the acrylic fiber manufacture or the especially for the fiber grade, that is the suspension polymerization, which give the high percentage of conversion, better product whiteness, shorter residence time and easy control of the polymerization. Redox initiation is normally used in the production of the acrylic fiber. The most common redox system consists of the ammonium or the potassium persulfate, sodium bisulfate and the ferric or the ferrous ion. Now, as I told you, after the polymer is made, the next step in any synthetic fiber is the spinning process, and depending upon the type of this your material which you are having, type of the your polymer which you are having, the different type of the spinning process that is available. That was the, I told you that the dry spinning, wet spinning, or it may be the your melt spinning. So, spinning includes the solution or the dope preparation, spinning technique and finishing operation including after treatment, cutting and baling. Dry spinning, in dry spinning of the acrylic fiber, dimethyl formamide is used, as I told you earlier also. The DMF spin dope contains the polymer in the DFM, thermosterilizer and delucence. And the DMF evaporated by circulating the inert gas through the tower at about 30 to 35 degrees centigrade. In the wet spinning, sodium thiocyanate are commonly used as the solvent. Wet spinning fiber is spun into a liquid bath containing a solvent, non-solvent mixture called the coagulant. Non-solvent is usually water. The fiber emerging from the spin bath are washed and dried, followed by cutting and baling. This is the process which you are having in case of the preparation of the acrylonitrile tow, or the cutting to staple fiber is there for the acrylonitrile. So, mixing tank where you are using the where adding the acrylonitrile catalyst, or if you are using the comonomer, so then the comonomer will be also there. Jacketed polymerization, the monomer stripping which is recycled back, and then the slurry handling, centrifuging, polymer storage, then dissolver. Dissolver, here we are having the dissolver, but there this here you see the what is happening here. It is being passed through the spinning bath, and after that whatever the threads are there, that is going for the drying, crimping, annealing, so tow, cutting. If you are in the staple fibers, then it is cut, and so the same case if you are interested in the your fiber staple yarns, then the it will go through the spinneret. Here actually if you see, in case of the here it was the wet spinning with the spinning bath. Here in case it is going from the a large number of the spinnerets are there, continuous moving and then rotating, and so the whatever the fibers that is done, that is going to the crimper, then the annealing, and the finally we are getting the acrylic fiber staples. Now let us discuss about the polyurethane, that is also one of the important polymers. So the polyurethanes are versatile class of the thermoset polymers and offer the elasticity of the rubber combined with the toughness and durability of metal. So basic polyurethane chemistry was developed in 1937 by Dr. Otto Bayer. In 1940, rigid foam was first introduced for aircraft. Use of polyurethane in adhesive between rubber metal and the glass introduced in 1941, not 1941. First insulation application in 1948. Introduction of the spandex fiber in 1958, and then it was the synthetic fiber industry before the textile. We started some of the polyurethane are also there, that is being used, especially the spandex fiber. The rigid polyurethane foams are most widely preferred to insulate and find application in refrigerator, manufacture of thermowares, cold store panel, refrigerated trucks and wagons. Polyurethanes find application in the form of film sheet, foam fiber, coatings, adhesives, sealants, because some of the resins they are also going to the coatings and adhesive purposes, for insulation of variety of tanks where it has lot application for insulation purposes, which we used to have the glass wool, vessels, pipes and domestic applications such as refrigerator, freezers, furniture cushion bags and armrests. Then the bedding, full foam mattresses and topper pads for inner spring mattresses. So these are the some of the broad application of the polyurethane. Worldwide demand of the polyurethane expected to grow at 5.8% from 12.0 million tons in 2010 to 116.8 million tons in 2016, with Asia Pacific region accounting for over 60%. Polyurethane is polymer formed by combining two or more isocyanate functional group and two or more hydroxyl group, that is the polyols. Commonly used isocyanates are toluene diisocyanate. This is the one of the major consumer of the toluene, as I told you earlier while discussing the aromatic. Diphenyl methane diisocyanate, hexamethylene diisocyanate, HDI. Polyols may be either polyether polyols or the polyester polyol. The catalysts used in the polyurethane manufacture are aliphatic and cycloaliphatic tertiary amines and the organic tin compounds. This is the reaction, typical reaction that is taking place in case of the isocyanates and the polyhydroxyl compounds, which is we are using for the making of the polyurethane. Another type of the that is now it has become important in usage, that is the polyurethane foam. So, polyurethane rigid foam are characterized by good structure strength, excellent adhesion to most substances, processing flexibility and longer life. So, these are the some of the advantages of the in case of the polyurethane foam. So, this was about the acrylic fiber, modified acrylic fiber, and then about the importance of the acrylonitrile and the polyurethane fiber, because the acrylic fiber, as I told you, that has replaced because of its low cost the conventional wool material, which is now just like in the cotton, that has been replaced by the blend of the polyester and the your viscose rayon. So, the in case of the synthetic fiber industry, the cellulosic raw material based fibers are also playing very important role, and they are also very important sector, although it is not considered a part of the organic chemical industry or the petrochemical. It is more concerned connected with the pulp manufacturing or the pulp and paper industry, because some of the paper industry they are making the your rayon gate pulp, and that is one of the century rayon which is having one unit, and Harrier pulp. Birlas, they are the pioneer in case of the making of the rayon in the, it may be the viscose rayon by Harrier polyfiber, by Grasim industry, and that is they are having at Nagda. So, this is the importance in case of the viscose rayon. Then we are having the state rayon which is having the silk like appearance, and so that will be discussed in the next lecture, in the lecture number 8 of this module.